Okay, guys, I'm gonna need you to finish this today in class. This will be a grade, it will be a check. We will address it as soon as I return. Thank you for taking care of your responsibilities while I'm gone. So you might need to refer to our foldable that we did on Friday to help you with some of these problems. But I am going to go over each section just to make sure. But the main thing is you have to know your constant of variation, your equation, and how the graph is supposed to look. So mainly you need these three sections, and there was examples of those parts that we did. So that's what I'm saying. Refer to the foldable if you need some assistance. Now, the first question here is they want you to determine which one is not an example of a direct variation. So a direct variation has to be in this form, y equals kx, k times x. So on here, you're trying to pick the one that does not have that. And anytime we're doing adding or subtracting to the slope, it's not going to be a direct variation. It's not going to go through the origin. Now, using that form, okay, I'm going to just rewrite it here, y equals kx. They want you to name, on this next section, the constant of variation, which right here says the k. So what you have to do, is look for what's in front of the x. So like on number 2 here, the k would be 5. That is the slope, which is our constant of variation, okay? So we're just trying to make sure you're picking the correct part. And the constant variation does not have a variable. It should be a number every time. Now, on this next section here, 5 through 8, all right, this is write the direct variation. First, I want you to write the direct variation equation. That's basically what I was talking about on the first two sections. And it has to relate to the two variables, okay? And then solve. So because in the statement here, suppose y varies directly to x. Varies directly to x means y over x, which is how we get to our k. So we're going to use this ratio to find the k. So here, since I know this is what the k equals, sorry. Since I know the y is 16, the x is 8, we're doing 16 over 8, which equals 2. So that's our k. They want us to write the equation using that k. So the equation would be, because it's going to help us find the y, okay? So the equation is y equals 2x. Now, in this problem, in this last section, it says find y when x is 16. So what you're going to do is take the value of x and plug it into the equation. So that means this would be y equals 2 times 16. Well, 2 times 16 is just 32. So our y would be 32. Okay? So this is what we want you to do. There's several things, and not just one step. You have to first find your k. Okay? So kind of maybe focus here to get to that k. Okay? The y over the x. Oops. The y, which is 21, over the x. Then write your equation. Okay? Y equals, I know this reduces to 7, so that would be 7x. Then take the value of x and plug it back in so you can find the y. All right. So once you complete these problems, then when you look at 9 and 10, determine if each graph represents a direct variation. There's two things that has to happen for it to be a direct variation. First thing, it has to be a straight line. Okay, a straight line. And that straight line has to go through, I'm probably running out of room here, sorry, the origin. And the origin basically means goes through the 0, 0. Okay, so check that the line goes through 0, 0. Now, if it says if it is a direct variation, so it says if so, write the equation. To write the equation, because the equation is y equals kx, you have to remember your k is your slope. And that basically means you're looking for the rise. Sorry, let me rewrite this. Sorry. K is your slope. So we're looking for the rise over run on the graph. And in order to do that, you need 2 points. So you might need to plot the points. And pay attention to your scale. We'll talk about that big time when we'll check this. All right, so that's the first page. We flip it over to the back. Now we want us to determine if y varies directly with x. So like I said, if you look at our flip book, this is when, oops, I want to do this. This is when we looked for that ratio between the numbers. And we need to find that ratio of all the numbers and make sure to see if it's constant. Okay, and if it's constant, then we can write the equation. So a couple things you have to remember. The first column is your x, the second column is your y. Hopefully we see this is the origin. And because this is the origin, that's a big clue. But if you're going to do your y over x, which is what we're trying to calculate here, we just got to compare each one. All right. You want to compare each one. So like, for example, here, 55 over 1. What does that give me? Then we go to the next one, 110 over 2. Compare all of them. They have to be all the same. So please look at your notes again if you need to. And then you have 2 word problems. And I want to talk about the word problems. Okay. You look for some key information here. Now, on 14, we're talking about the distance from lightning varies directly. That's the lightning, the distance right here, varies directly with the time. Okay. And it takes you to hear the thunder. So this is like saying y, which is our distance, varies with time, which would be our x. So it says if you hear thunder 10 seconds after you see lightning. So 10 seconds is referring to time. It says here you're about 2 miles from the lightning. Miles is distance, so that's y. So to write a direct variation equation here, we're going to need to find that k. And to get that k, that's when we do y over x. So we're looking at our, what is it here? Our time, our distance, which was our miles here, over our time. And then this can be reduced to 1/5. Now, this is our equation y equals 1/5 x. Now it says estimate how many seconds it would take for thunder to travel a distance of 4 miles. And you can do that kind of mentally, because I know 10 seconds was 2 miles. I mean, there's a pattern there. But miles is if you wanted to solve the equation, miles represents distance, which is y. So if I was to plug this in, because this is a y value, this would be 4 equals 1/5 x, and we're solving for x. And in order to do that, you would have to multiply by the reciprocal. So 5 over 1. And then that would get our x, okay? So try to kind of come up with an equation based on the ratio, based on the relationship, and then let's see if we can solve this. So I want you to kind of do number 15, and then I know it's not on here, but you need to remember when you're done, you need to make sure you complete the ALEKS assignments. We're going to have to do better this 6 weeks and staying on top of our work, especially right before the end of the semester and final exams. So on Thursday and Friday, some of you had a decimals. Well, all of you had a decimals assignment, but not everyone got to it because we had quite a few people making up work. So make sure you complete that decimals, because at the end of that decimals was instructions to complete the ALEKS assignment. So there was an ALEKS assignment for 11. The most recent one is 11.6. And then there was one prior to that, and I think it was 11-2. Yeah. So both of those assignments are going to be a grade. All right, this will be a grade. We're going to start off really strong. And so I need you to kind of make sure you complete the ALEKS. So when you're done with this worksheet, please go complete ALEKS. All right, thank you for taking care of that, and I'll see you soon. Tomorrow.